Hello. Welcome everyone to this video. My name is Anmol and I am a software developer working in the Netherlands. I have created this Grasshopper plugin called Ant, which is your AI-powered Copilot. In this video, I will tell you a little bit about what I have developed so that you can use Ant in your workflows and hopefully get some use out of it. To give you a bit of a background, last year I attended the AEC Tech Hackathon in London and I pitched this idea of an AI Copilot in Grasshopper. And ever since that, I have been working on to make a commercial product out of it. Earlier this year, I was able to launch Ant to the public, and I thought, let's continue this. To tell you a bit of myself, I am a developer at heart, so I really like to build stuff, but I'm very bad at marketing. But I built this cool product, and at one point I realized that no one will know how to use it until I get myself out there and explain it to people. So here I am, and let's begin. So I have already opened the Grasshopper and the Rhino windows here. First of all, to install Ant, you can just open the Rhino package manager, and once that is open, you can search for Ant and you can install it here. After you have installed it, you need to restart Rhino, and after that you will see this Ant icon appearing on your Grasshopper canvas. So this icon is used to trigger the chat window. Here in the chat window, I will explain a bit like how you can work with it. So first of all, this is the icon to create a new to start a new chat. So in Ant, what we are doing is that for every message that you send in a chat session, we also send your chat history along with it. So after a while, the context can really compound and the LLM performance can degrade. So it is highly recommended that you keep on creating a new chat to refresh the context. This is the icon where you can access your previous chats and you can continue any chat session that you had previously. This is the icon to just toggle the light and the dark theme. And this is your account icon where you can authenticate yourself or send feedback, which is highly appreciated. And also you will see these two welcome messages. In the first message, we provide you the link to join our Discord channel, where you can become a part of the community which are discussing ideas, or if you have any bug reports, you can directly contact us on Discord. And you also have this link to our website where you can see the documentation, or if you want to upgrade your plan to a premium version, you can also do it here. And then we get to the main part. Here we have three icons: Ask, Edit, and Script. So these are the three modes in which you can use Ant. The Ask mode is basically a general purpose communication with LLM. So here you can select a bunch of components on your canvas and then ask the LLM to explain the algorithm behind it, or if there are some errors, you can ask it to debug it, or just get some help with planning. So you can just chat with an LLM with this mode. In the edit mode, you can actually have the LLM create native Grasshopper components for you on the canvas. So you can prompt the LLM to create some geometry, and it will find the required components and connect them and place them on the canvas. And in the script mode, it does sort of the same thing as the edit, but using C# or Python script components. So it will place these script components on your canvas and then create the code and inject the code into these components. This is how it will work, and I will show you with an example as well. And finally, we have this small icon, which is used to upload text files or images. So you can upload an image and ask Ant to generate the geometry for that as well. So that is an overview of how this chat window works. Let's get to the demo now. So for the demo, we will create a fancy stadium roof and divide the roof surface into panels, and then rotate the panels so that they point towards an attractor point. So let's start easy. Let's say create a circle and divide it into points. Yes. So here you see that the AI is asking you some clarifying questions. So as a user, mostly you will underspecify your prompt. So here we did not say what's the radius of the circle or how many points do we want to divide it into. So the AI is asking these clarifying questions so that it can generate an accurate definition. So I think I agree with all these default values that it has suggested. Let's see. Okay, yes. So it created this circle and it has divided into 10 points. Yes, that works for me. Now we will go ahead and I will use the script component. So as you can see that when I selected this component, I see this message here that tells me how many components I have selected. So this selected component will act as context for the LLM for the next prompt. So in the script mode, I want to generate a script that sets the Z coordinates of these points to follow a sine wave lying between a maximum and minimum Z value. So as you can see that I am just specifying these points. So it will take from context that the user has selected this component which has an output points, and it will just use that. So let's see how it works. Of course, it has some clarifying questions. I actually would like to go with the C# component and minimum 0 to 10. I think that's fine. I have seen that the performance of C# scripting is quite good. Like that is my go-to mode for any sort of component algorithmic generation in Grasshopper. Okay. So as you can see here that it has placed a C# component and connected the points and also the sliders, and it has automatically given me a frequency slider as well. That's nice. And now it is generating the code and executing it. And as you can see that it has done a pretty decent job at it. Let me switch off the preview for all of this. Yes, that is something that I wanted. Let's put it to 2 maybe. I'll just set it as 2. And I want more points. Let's say 20. Okay. Yes. And I would like to give it a bit more. Yes. I think I like this roof now. Although I do see this weird dent. I think that might be because we have set the frequency to 2. Maybe I can, maybe this looks more smoother. Yes. Okay, let's just go with this right now. In reality, you would need to be more precise with these values, but for now, it looks nice to us. Okay, so it was able to generate the code, and you can also see it. So if you open the component, all of this code that is generated by Ant, and it has been injected into this component as well. So it's working fine. Now I will just go here and I will continue, and let's use script now, edit now. So I say I want to create a closed smooth curve with these points. So I need to connect these points to a curve. Let's see what it does. Okay, it used an interpolate curve and it made it closed, and you can see it did a decent job. Okay, nice. Nice. And let's go ahead, and now a bit of a technical challenge for and now we want to create a ribbon around this closed curve. So a ribbon like surface. So I will just prompt it that I want a flat ribbon surface such that the curve is in its center and the width extends in the XY plane. So let's see how it does it, because this is a more complex part of the job. And you can see here that I am not telling Ant to create the entire thing in one go. And I would not even recommend doing that, because if you do that, you have no idea about the algorithm that has been used to create this definition. Okay, it was quite fast actually this time. And I can see that it was able to correctly create the surface that I wanted. And it also gave me this width slider that I can vary. Nice. So you can see that it was able to create this, and it created this part of the definition. But I don't know what the logic behind this is. So this is actually a very good example to show for the ask mode, that explain the logic of the selected components. Be brief. Okay. Okay. Let's see. Okay. So it says that the definition builds a flat ribbon surface centered on a sine wave curve. Yes, that's fine. So there are three stages. The center curve. Okay, we also selected the creation of the curve. Then it's fine. Yeah, the bilateral offset. So it says the ribbon width slider provides half the width value. So the one offset curve use the raw positive value, offset to one side, negative negates the slider, and both offsets use XY plane and a panel. Okay. And then we merge the two offsets into a single two item list, and we loft it. Okay. So basically what it's saying is that with the interpolated curve that we created here, we use the offset with this width on either side, and then after creating these two new curves, we loft them to connect the surface. The algorithm looks nice. Okay, so interesting. Now we already have it. Let's go ahead now. Now we can divide this surface into trapezoidal panels. So I will use again the script component for that. And I'm gonna do this again, and I will ask it create a new C# component to divide the ribbon surface into trapezoidal panels. And I will be more specific this time. The trapezoids should be created using the inner and the outer boundary of the ribbon surface and divided. I think that should be fine now actually. Let's see. Okay. Yes. Finally. I think it was able to do it now. So yeah, we have 20 defined surfaces, and let's see if I see list item and I want to see all the 21s. Yes, perfect. So yeah, it was able to do a nice job. So also this is a very realistic example on how an actual workflow will look like for you. Now I will create a point myself, construct point, and let's give it some range. Actually, I want to give it a minimum of -40. Okay, and I will create 3 copies of this and attach it here, and I will rename this as attractor. Yeah, naming your components intuitively can help LLM to understand your definition better. Okay, so what we will do now is that um, we will rotate these panels along their inner curve so that their normal is aligned to the direction vector to this attractor point. So basically, they are facing perpendicular to this attractor point. So let's do that. And I select both of these, and I open and I say um create a C# component that rotates the panels about their inner curve so that the direction vector from their center point to the attractor point is aligned with the normal of the surface. Okay. Also have a maximum allowable angle to which the panels can be rotated. Okay. Let's see. Yes. That is exactly what I wanted. So let's just make the preview of. Actually, I do want the preview of the attractor point. Yes. So now if I move this, they are changing the angle to point it to okay, nice. So yeah, so this was how you can use ant. um, it did a decent job, I would say. Yeah. So you can also use ant in your workflows, and please join our Discord channel and let us know what you think about it. If you have any suggestions to improve on it, then they are very much welcomed. And one last thing I would like to note is that right now Ant does not support third-party plugins, but that will be coming out in a few days. So after that, you can also work with third-party plugins with Ant. That should be really useful. And if you have any comments or suggestions, please let us know. Thank you and have a nice day.